All right, let's talk about unique pointers. A unique pointer is a kind of pointer that owns the piece of memory it points to. So we cannot have two unique pointers pointing to the same memory location. For that, we have to use a shared pointer, which is the topic for the next lesson. So let's see how we can work with unique pointers in C++. First, we go on the top and include another file from the standard library called memory. In this file, we have a type called unique pointer, which is a class. Now, we're going to talk about classes in the next part of the course, but for now, think of a class as a building block that can contain several functions. So here we have a class, and this is a generic class, so it can work with different data types. So right after the class name, we type angle brackets, and inside the brackets, we specify the type of pointer we want to create. Int. So this is going to create an integer pointer, okay? So this is a type. Now we need to give our variable a name, like x. Then we type a pair of parentheses, and inside the parentheses, we use the new operator to create an integer pointer. So essentially, we're creating an integer pointer here, and then passing that to this variable, which is called an object. Now, this object is an instance of the unique pointer class. So in this class, we have a bunch of code, we have some functions, and one of these functions is going to be responsible for deleting this integer pointer that we have created over here. That's why we don't have to worry about deleting this pointer, okay? So here we have a unique pointer. Now we can work with this just a regular integer pointer. So if we print it, we see a memory address. There you go. We can dereference it and store some value here and then print it. Here it is. But we cannot do pointer arithmetic. So we cannot increment this. We cannot add 1 to it. We cannot perform any arithmetic operations on it. This is the limitation, okay? Now, there is a simpler way to create a unique pointer. We have a helper function called makeUnique, which is a generic function. That is why we see angle brackets right after the function name. So this function can work with different data types. Now here we're going to create an integer pointer, so we type int here, and this will return an instance of the unique pointer class. So we declare another variable of type unique pointer of int. We call that variable y and set it to the return value of this function, okay? Now we can make this code even shorter. In this case, we don't have to specify the type of this variable because we can see that we are creating a unique pointer of type int. So there is a bit of repetition in the code. This is where we can use the auto keyword to simplify our code. So we're letting the compiler infer the type of y, which is unique pointer of int, okay? So now let's call this function one more time and create another unique pointer called x. So make unique of int, and we store it in x, okay? Now we don't necessarily have to use the int data type here. We can use any data types. For example, we can create a unique pointer to an integer array, but here in parentheses, we have to specify the initial size of the array, let's say 10. So now we should call this numbers because it's referencing an array of integers, okay? Now we can use the array notation to store a number in this array and then print it on the terminal. There you go, okay? So this is how we can create unique pointers in C++. Now, as you can see, with these pointers, we are not going to use the delete operator to deallocate memory. All of that complexity is hidden inside the unique pointer class. Next, we're going to talk about using shared pointers.